So, today we are going to have a brief, not I'll say brief, some amount of description about center of mass and angular moment. So, we have been aware of how we have been dealing general Lagrangian equations of motion. Now, what if you remember in your earlier classes, you might have studied center of mass. It's the point where the all mass is supposed to happen. So we take average of the mass around that common minimum or common point, which is assumed to be that center of mass. And it may vary from problem to problem. For example, for two body problem, we have mu. Mu is equal to m1, m2 divided by m1 plus m2. So normally we take m sigma m, and m goes to 1 to m. So as such, a center of mass is a very dynamical quantity. If a body is assumed to be at rest, we can find from symmetry or other consideration where exactly center of mass is located. But if a body itself is moving, so it's different particles may also be moving, having different velocities and different orientations and different directions. So it becomes a problem how to arrive at how to identify center of mass, and it becomes more problem of interest for us because we have to define things in terms of Lagrangian number system. So we are not talking in the traditional way. It's a Lagrangian formulation of mechanics. So how we can reformulate our understanding of mechanics vis-a-vis this Lagrangian dynamics. What my point? So this is the general. So what we are going to say, what is center of mass? Center of mass means the definition is that the mass is supposed to have equality, but we are taking it how center of mass is a reference frame x and there is another k prime. If one of the frames is at rest, another is moving, or both of them are moving, or both of them are at rest, or one is moving relative to some relative without the other frame k prime. So how will the reference frame, for example, if the frame k prime, we are having a velocity v, and another frame which is k, and the velocity frame k prime and ka are the velocity frame. This is ka prime and this is such that the relative velocity of frame A vis-a-vis frame another frame is this. So one frame, the relative velocity of one frame can be written like this. So how we see momentum? Momentum as a quantity is not ma. But you can see it is velocity. But it is the relative velocity of two frames. So this velocity, which is moving, the body is moving with regard to its another frame, which we are going to measure. So we are going to just see this is for acid value. We are going to substitute it here. So and A, so B whatever write it as B prime, and the other term will be this. So if it's MAVA, but if V is some constant, relative velocity comes to, it will come out. It can come out close. And this sigma is A to n. And means number of particles, one particle, two particles, all these are going to the center of mass. So this. So now what we say that there is always a reference frame k prime in which the total momentum is zero. Which total momentum is zero. When it's zero, when body rests zero, the body is at rest. So because the velocity will be zero and maybe will be zero. So if it is that way, then so if we write it like this, we can first write this equation as P is equal to this momentum is equal to P prime plus V times sigma A there is a possibility of putting P prime is equal to 0. If the body is moving, these are the another frame, that the frame is supposed to be at rest. So the relative can be at 0. So the velocity, the relative velocity, so P will be equal to V times sigma A, or from this V may be equal to this P by sigma A, or it will be equal to sigma times MA VA by sigma. So this is our relative frame, relative velocity of a body. With respect to, if we take one of the reference frame is at rest and another reference frame is moving. So this is the relative velocity. So it depends upon total mass, the solution of that mass. And if you write the figure in the class, you can write use the notation mu. Mu is the not the top of reduced mass, but you can take as the mass m1 a1 plus
M1 x1 plus M2 divided by M1.
so you can write it like mu. So mu, if you write mu as sigma ma
V, sir, in terms of velocity.
so you can, this also expresses a property called additivity of mass. What do you mean by additivity of mass? If you remember that in the closed systems, and which also follow the property of conserved system, if you increase the total number of particles inside the system, there is a property of additivity. So the property which you are going to impose on the system, they are going to add individually. So I said that if you multiply a function by f, and f is equal to f1 plus, so f of f is equal to f of f1 plus f of f2. So if there is any property which you are going to impose on the whole system, so that property can be taken by the parts of the system also. So in the same way, if there is mass f, it's not one mass. You can add n number of masses. So it's following additivity property of the mass. It's following that. And radius from radius, it will come like can cancel this. This is sigma of r1 plus r2 plus r1 is this will have rewritten this expression like this. This is momentum. So this is mv. V now he is saying the right hand side. So if we can write this equation as a total time derivative of the expression. Total time derivative of the expression means what? You can also write it as dr by dt. So you can also write it as dr by dt cut जाएगा, or you can write it also as like this from this one. So now what we are going to see is that if we want to see the same thing in the simpler cases, what we have studied here, another way of rewriting this property of a closed system, which are following this additivity. Another another way of how we can say this thing is that for a closed system, you remember we say that for a system, for an inertial system, the center of mass lies with its own center. The center of mass coincides with the center of the given body. It's the property of inertial systems. Okay. So this property can be taken as a natural extension of this closed system. This which is having these properties. Which is having. So, but if you want to represent it in terms of energy, what we are going to know that the total energy of the system is 1/2 mu. Mu is total mass plus this is you can take it as potential energy or u is the potential energy. So if you have two reference frame, or E is the internal energy. E is the, this is the kinetic energy. So it will depend upon position or configuration. So if it is like this, another way of, if there are reference frames K and K prime, and the velocity is VA prime plus V related to these reference frames, the total energy can also be written as MA square. So now you can write it as U. So इसके बदले we are going to write it as Q dot. No, we are going to write VA के बदले हम write this. But it is written as we are going to write VA prime plus V is square, but it's not square. It's just a dot product in a sense. Square we have, but it's each individual we are going to take turn by turn how they will pan out. Because these are the components of VA. It's a dot product is this with this. It is square, but the proper it's a scalar. So we are going to see how we can write it, how it will simplify plus. So you can write MA, this is sigma, you can write it as U. So you can have four terms. This may be here. So VA prime square, V square, and VA prime, VA prime. Divided twice A B prime. So 2 एक से सब कट जाएगा. So we will have three terms like, and mass we can represent as mu. We will write it as V square plus V dot this. Discussion 2 I will cancel one of the 2. It will be and V dot plus 1 sigma A. And VA prime square. So this will be equal to V prime plus V dot. This is V prime plus. So you can write it as VA square. Or you can write it, if it's sigma, you can write it as mu VA square. And if one of the frames is that configuration will not change, position will not change, you can write this thing as this. So this is the general energy of a system having relative velocity vis-a-vis another system. The expression can be like this. Okay. Now what we are going to do? Now what we are going to do we are going to start a bit of description about Lagrangian of we are going to see angular momentum. And angular momentum with respect to how we have defined Lagrangian of a system. Where we are interested in how Lagrangian changes with dA, dl by dx dot, and dl by dt. So that taking that formulation, we are going to see how we can this is the radius vector. So you have r, theta, and phi. So these are three coordinates. So if somebody is body is rotating, you have it will rotate around some axis. So you have r, theta, so we have whichever coordinates you are going to have in space. So you can also write x in terms of r cos theta, y is equal to r sin theta, or x is equal to r sin theta sin phi. So you have to see how we can represent angular moment quantity. Angular momentum is a quantity which may depend upon coordinate system to coordinate system. And it's also a problem in Lagrangian dynamics, how we can identify a given coordinate system. किसी coordinate system के लिए Lagrangian के लिए हमको spherical coordinate जरूरत है कि elliptical है any coordinate system. That depends on choice, nature of problem कैसे. That is the basic job of how to identify the proper coordinate system which is required for that problem. Okay? So in our case, this time अगर ये हमारा this is the radius vector, this is the angle theta. This is delta phi. This is all. So now what we are going to do is that there is a property called isotropic property. What's isotropic? Isotropic means, for example, if we are going to rotate or change some quantity in space, now you are going to have some translation. These are in the same space, in the same space. The properties of the system will not change. For example, if the total number of energy of the system of that particle has been conserved, if you make some translation or some infinitesimal change in the rotation, so you have changed the axis a bit in a translational manner or in a rotational manner. The intrinsic properties of the system, of that whole system, they are not going to change when we have that translation. So that is known as isotropic. Space is isotropic. In whichever direction a quantity will, the components of that quantity will change its magnitude, it will change in a uniform way. It will change in a, so the quantity may be linear momentum, then we have linear momentum and linear conservation problem. If the property is rotational invariance, space, so we will have properties of angular momentum. You got my point. So isotropy in linear space and isotropy when you are in a rotating frame of reference. These are have to be identified. So if you have the radius vector, for example, delta r, thereby also write it as sin theta d phi. So it depends upon radius vector will depend upon this and this. If the delta r is perpendicular to or delta pi. So delta r is change in the radius vector. Just like आपने क्रॉस प्रोडक्ट पढ़ा है ना, E cross B, propagation of electromagnetic wave is perpendicular to E field and B field. So in the same way, you can have change in the radius vector is perpendicular to or phi. So that means delta r is equal to delta phi cross r. Or if you have a, if you stop derivative करेंगे, it will be delta r by delta t dr by delta t is equal to cross. Now, if we have our knowledge of Lagrangian system, the Lagrangian system may depend upon how the Lagrangian, which in the traditional sense is a kinetic and potential energy inside the system, which depends upon how its coordinates and velocities के साथ कैसे change करते हैं. So if you just take coordinate and velocity change in Lagrangian system, not time. If time will over, then we have to do dl by dt extra. So dl by dr is yesterday also said this is delta. This is del. Infinitesimal change in Lagrange or infinitesimal change in the total energy of the closed system क्या होगा? ठीक है? Under the condition that space is isotropic. So we assume that if the space is isotropic and the system is closed, the Lagrange infinitesimal change or change in the system, total energy of the system will not change. It will remain constant. That we have to verify what is the change in the Lagrange. With regard to space, कितना होगा infinitesimal change and Lagrange and how it changes with regard to dA. This is delta x dot. This is the expression. Assume that in a closed system and the space is isotropic, the total change in the Lagrange or total change in the energy will be 0. So now you can replace dl by dr को कैसे आप replace करेंगे? You can also write it as PA and dl by dr, dl by dr is equal to PA, dl by dr is equal to our d dot s. And if you remember, d by dx dot of 1 by mx dot square plus b. इसका क्या आएगा? It will be dx. That's dl of this. Now, if you only have this symbol is dl by dx only. So this will be 0, it will be dv by dx. dv by dx is equal to force. Force is equal to m dv by dt. That will be equal to p dot. So we can replace dl by dr dot or dl by dr dot is also dv. इसके बदले we are going to write dA and इसके बदले we are going to write d dot. ठीक है? So taking these substitutions, the equation we have for sigma E. If you write P dot delta R के बदले पर हम write in presence in absence of delta R, we will write this delta phi cross R. In the same way, we write PA dot delta phi cross R is equal to. Now, if you permute these two terms and taking delta phi, so बाहर निकालिए, we get R across this plus P across P cross or B are this one is sorry, this term here. B cross or you can write delta phi dot. So if you इसको आप you can also write it like this d by dt of जिसको हम UV form में, you can also write it as UV form और A cross E कैसे? एक बार आप इसका डेरिवेटिव निकालोगे तो क्या आएगा? B आएगा, so B cross E निकाल देगा। दूसरे में आप R को बाहर निकालोगे, ये आएगा P dot. You can write this thing also like this. So you can write this thing like this, and but before delta phi is arbitrary, we can take. So यहाँ से divided by this, it will be 0. So from this, we can say d by dt of or A cross PA जो होगा हमारा that will be 0. And from this quantity, remember this is MA BA cross R. वो हमारे पास कौन सी क्वांटिटी होगी? एंगुलर मोमेंटम. So from this exercise, if you have infinitesimal rotation, ठीक है, vis-a-vis these angles theta and phi, and radius vector R. So at taking this Lagrangian of that system, क्या आएगा? Compute that Lagrangian, assuming that there is isometry of the space, the total energy of that system under some translation. Rotational translation, linear momentum. The angular momentum होगा तो isometry in terms of rotation. So we got that this angular momentum m को हम ऐसे लिख सकते हैं. So it's constant or we can write it as this. This is the angular momentum or moment of momentum. Moment of momentum or angular momentum of system. So now the way we have to compute the integrals, किसी भी differential equation को, just like I said, Newton's first law minus md2 by dx. So we have to calculate the constants of integration. In the same way, this is a differential equation. So what are the constants of integration? Or what are the integrals of motion? जो हमने start of the chapter में किया, we have to find them, if you remember. What are the integrals of motion, which will determine motion कैसे? For example, we should know whether the body started from rest or it already had some velocity once it had gone यहाँ से. So in the same way, जो integral motions हैं for the rotational dynamics, or those constants of integration which will specify उसकी motion क्या है, ठीक है? So we might require those energy, three components of momentum, key components of environment. Now again, we are going to do the same exercise we did previously. Now we did for simple center of mass. Now we are going to do the same exercise in a sense if there are two reference frames which are rotating. Relative motion of one reference frame vis-a-vis another reference frame. Such that जो radial distance है, for example, और A और जो है हमारा और B और A prime plus A. So जिस तरह हमारे पास एक सिस्टम एट रेस्ट था and another system was moving. We try to see a momentum between those reference frames there, the relative velocity there, center of mass there. Now, if one of the systems and radial vector r and दूसरा reference frame है, it's also rotating, but at some constant distance. जो particles हैं which are rotating, the total number of particles which are rotating vis-a-vis that center of mass. Now it is changed by some constant distance. यहाँ भी rotate कर रहा है, कुछ distance add rotate कर रहा है, ठीक है? और A is equal to R A prime plus उससे क्या फर्क है? So what we are going to see is जो हमारी ये है distance, so we are going to see. What is the momentum if it is given by M or A cross E? R के बदले we are going to write this. It's R A prime plus E. So I go to take step 2. I'll just so it makes R is this P plus A cross of or so we write it this R A cross P के बदले we are going to write it and line plus A cross E. So now if you assume that the second reference frame is at rest, so you can take momentum होगा उसका क्या होगा? So then you can say MA is equal to MA prime. So this is a simple property. So just like two reference frames which are moving at relative velocity in a given isotropic space. So अगर एक frame reference frame rest पे है तो दूसरे पे कोई फर्क नहीं. Now in the same way अगर rotational dynamics में लेंगे two particles, two big reference frame, one rotating frame, the other reference frame उसका है and if the other reference frame is rest, so it will not have any, it will not make any difference. This is the point. This book is trying to आपको एक बात बावर करना है, I want to emphasize this. This triple does not affect the law of conservation and the momentum. And now it's for radius vector. You can do the same thing for if you take BA, it's going to be BA prime plus. You do this exercise again. So हमने ये radial vector किया. Now if you do it for velocity, so VA prime is equal to VA plus this is, so it will be MRV angular moment, MRV prime plus MRV prime. So you can write it like this. If I write it as अब ये what he is trying to say is this. He is मतलब है जो ये बुक का ऑथर है या I say the subject of mechanics is saying like this. ठीक है? When I am saying that he means the different books may present the mechanics in different ways. वो उसको क्या कहते हैं? क्या कहते हैं? गालिब का अंदाज़े बयां कुछ और हर किसी जो फिजिस्ट है अपने अपने बात तो वही है. Different books have different ways of saying that. But you should yourself as student identify आपके लिए कौन appreciable है. So he is trying to say the subject of mechanics is conservation of angular momentum and conservation of this linear momentum. But the conservation of momentum vis-a-vis what? Vis-a-vis Lagrangian formulas में how we can state it. So in the same way, so if you write it like this. So again, we are going to write BA के बदले हम लिखेंगे this BA prime plus B. Or we can write M is equal to, if you write this as A prime plus इसको हम और अब यह है कि this was starting point here that so this is this angular momentum of one frame is something how we can relate to these two reference frames. Write it like this. और so ये है कि the angular momentum of a given body is basically total intrinsic momentum which may be at rest or total momentum as a whole. So intrinsic momentum क्या हो गया? Which is having it, it's going to have it. पर अगर body at rest है, the momentum may be zero. ठीक है? Vis-a-vis that system. So अगर आप two reference frames हैं, we are going to relate them to reference frames. But one of the frames is at rest, so we can take it as zero. So but it may not be necessarily rest. So you have to take this thing, into consideration. But providing the fact that for a closed system, total energy of the system will remain constant. So this means Lagrange, when you are going to calculate the Lagrangian of the system, Lagrangian of that system which is rotating, ठीक है? तो उसमें total energy of that closed it will remain constant. It will remain constant. न ज़्यादा होगा न कम होगा. That statement of conservation of mass or energy, ठीक है? In that sense. अब इसमें सिर्फ ये आइडेंटिफाई करना है कि ये है ना how it's going to rotate. When things are rotating, the components may vary from coordinate system to coordinate system. For example, intrinsically, if you rotate a ball in an ellipse, or you rotate a ball along a circle, these are different examples. तो उसमें Lagrangian, how you are going to set the Lagrangian, कि components कैसे आप set करोगे? Or the more complicated problem is that particle is oscillating as well as rotating also, as well as having linear motions. Okay? So you have to see the Lagrangian of the system total, but model the fact that at the end total energy Lagrangian is constant. अब उसी को if in cylindrical this book has given a problem, for example, which I only state. For example, Lagrange अगर किसी भी सिस्टम को होगा Z ऑर्डर में x a is equal to mod a cos y a or a okay. So कोई पार्टिकल है, फॉर एग्जांपल बॉडी मूव कर रहा है ना इन सर्कल, हम क्या कहते हैं x इक्वल टू और cos theta, ठीक है, so इधर x square plus y square is equal to आगे नहीं इक्वेशन ऑब्जर्व किया। In the same way हमको देखना we have to see how the Lagrangian of a system is। अगर एंगुलर मोमेंटम है तो हमारे पास ये phi वैल्यू, Lagrangian of a phi or phi dot, अगर phi हो गया phi is on space, if it's moving in space so velocity will be opposite, you are going to write phi dot। So in a given problem which has shown, so angular momentum of this can, so you do it, you see it at your place, x is y dot minus y is x dot, angular momentum को ऐसे लिखते हैं, L is equal to pxy minus ypx, है ना? Now only thing is that x a and y के बदले we have to write this x dot and y dot निकालो, ये आएगा phi dot, ये sin phi आएगा minus sin cos phi आएगा minus sin phi dot, cos phi dot, उनका दोनों का इसमें we are going to see the Lagrangian, so you just put it at your place, phi is, so Lagrangian of the system will come out to be or E dot square or this one। इसमें यह है कि हम जो इसकी subsequent the problems you are going to see how you have to set the Lagrangian for a given problem, rotational dynamics, but the consideration is theta phi, how you can relate those parameters with regard to the problem। उसी हिसाब से you can see this phi को आप कैसे change करेंगे parameters, then how you find the Lagrange, total Lagrange system। Okay, so today is what we have already learned, conservation of angular momentum, but now we have studied in terms of Lagrange, ठीक है? Once you do or you study problems at least, you will see इसकी क्या intrinsic advantages है, ठीक है? Which I'll again and again exercise।